Every time you ask ChatGPT a question, every time you scroll through TikTok, every time a self-driving car detects a pedestrian, a staggering amount of computation fires off behind the scenes. And here's the part almost nobody realizes. None of that processing happens in the cloud. Because the cloud is not magical, the cloud is not virtual, the cloud is a place, a physical, enormous, very real place, a place filled with machines, a place called a data center. Without data centers, the modern engine rooms of the digital world, artificial intelligence simply wouldn't exist. No ChatGPT, no image generation, no voice assistants, no recommendation systems. Today, we're going on a deep dive into how data centers power modern AI, why AI workloads are fundamentally different from anything that came before, and how these facilities are being reinvented to handle the future of machine intelligence. Artificial intelligence has an appetite unlike any technology in history. To train a single large model, like GPT-5, you need tens of thousands of GPUs working non-stop for weeks or even months. A laptop couldn't train an AI model in a lifetime. A corporate server room couldn't do it in a decade. AI requires something far more extreme: parallel computing, petabytes of storage, ultra-fast networking, and an energy supply that rivals a small city. When training a model, GPUs need to communicate constantly, passing gradients, updating parameters, synchronizing states millions of times per second. And every one of those operations requires bandwidth, cooling, power, and low-latency switching fabric. This is why AI must live inside data centers. They are the only environments engineered for this scale. When you hear phrases like 100 billion parameters or trained on 1 trillion tokens, you're not really hearing about AI, you're hearing about infrastructure, physical, heavy industrial infrastructure. Let's step inside one. You walk past reinforced walls, through biometric scanners, and into a massive hall filled with row after row of black metal racks. Walk behind the racks, and you'll find a maze of thick power busways feeding the servers with massive electrical current. Look up, and you'll see cold air distribution systems blasting chilled air through the floor or ceiling. Walk further, and you'll hear the deep hum of cooling towers, chillers, and pumps moving thousands of liters of water or coolant every minute, because GPUs today run so hot that air alone cannot cool them anymore. Data centers are switching to liquid cooling and even immersion cooling, where servers sit submerged in special non-conductive fluids. This isn't the future, this is happening right now. Behind the scenes, giant transformers step down high-voltage electricity. UPS systems sit ready to instantly take over if the power grid fails. Diesel generators, enormous engines the size of cargo containers, wait outside to keep everything alive for hours or days. The entire ecosystem is built around one goal: keep the GPUs running no matter what. Some of the biggest companies in the world are now building data centers purely for AI. Microsoft and OpenAI designed entire supercomputing clusters inside Microsoft Azure. We're talking about thousands of NVIDIA H100 or H200 GPUs wired together through high-speed fabrics, operating as a single giant machine. Google took a different approach. It created its own chips, the TPUs, and built facilities optimized around them. Meta constructed the AI Research Supercluster, one of the fastest AI training environments ever built, to power future AR, VR, and generative models. Alibaba is building AI-first campuses across China to support billions of transactions, language models, and recommendation engines. The pattern is the same everywhere. AI doesn't run on laptops. AI doesn't run on phones. AI runs on data centers. But powering AI comes with massive challenges. Electricity is challenge number one. One AI cluster can consume the same power as tens of thousands of homes. Cities are warning that future electrical grids may struggle to keep up. Cooling is challenge number two. GPT generation GPUs run incredibly hot. Traditional air cooling isn't enough, pushing the industry toward liquid cooling and immersion technology. Cost is challenge number 3. Building an AI-ready data center can cost hundreds of millions, even billions of dollars. And supply chain limitations are challenge number 4. Even the biggest companies struggle to obtain enough GPUs, networking equipment, high-bandwidth memory, and optical components. AI has pushed the limits of global manufacturing, so what comes next? We're entering a new era, the era of AI-specialized data centers. Future facilities will use liquid immersion as default, support racks consuming 100-300 kilovolts each, rely on photonic networking instead of electrical, use AI to manage cooling, airflow, and workload scheduling, integrate renewable power directly on-site, capture and reuse waste heat to warm cities or industrial facilities. We'll also see modular AI pods, prefabricated data center blocks shipped on trucks and deployed anywhere the world needs compute. And eventually, the data center itself will become partly autonomous, an AI running the AI factory. So, in conclusion, the next time you use ChatGPT, or watch a video recommended by an algorithm, or see an image generated by AI, remember this. It all started in a building, a physical, humming, buzzing, glowing building full of machines, a data center, the true backbone of artificial intelligence. If you enjoyed this deep dive, subscribe for more long-form explorations into the world of data centers, AI infrastructure, and the technology shaping our future. And check out my shorts, where I break down the most surprising facts about data centers in under 60 seconds.